Okay, welcome to the ReGenX generator demonstration. The title of today's demonstration is 24,200 trillion to zero. Okay? The 24,200 trillion to zero ReGenX generator demonstration. So basically what I'm going to do in this demonstration for you guys is I'm going to give you an introduction to the technology. I'm going to try to give you a scope of the innovation so that you, when you leave here, when you're reviewing this later, you have a good idea of what the technology means on a global scale, the scope of the work that's required, and then basically giving you an idea of what you're getting yourself into, like in real terms, without holding anything back. So, in 2017, the world consumed 24,200 trillion watts of electricity. And conventional generators, with a conventional generator that we're using today, if you want to generate 24,000 trillion watts of electricity to the world, to supply the world, you need a minimum of 24,200 trillion watts of mechanical input power in the drive shaft to drive the generator. Okay? Minimum. If your generator is 90% efficient, you need 26,000 trillion. If your entire system is 30% efficient, you need 41,000 trillion mechanical watts to deliver your 24,000 to the world, okay, where it's consumed. Currently, 14,500 trillion watts are produced from fossil fuels, 2,400 trillion watts from nuclear power, and that totals about 16,000, almost 17,000 trillion watts of pollution. Okay, CO2 emissions, nuclear waste, and so on. And this is where China is having problems with the coal-fired plants that are polluting the air and poisoning the citizens. So the question is, why does it take 24,000 trillion watts in order to generate 24,000 trillion watts? And the answer is generator armature reaction. And I'm going to introduce you to generator armature reaction in a second. Generator armature reaction is also known as motor action in a generator. It's a counter-electromagnetically produced torque, and it's referred to in electric vehicles as regenerative braking. Okay? So, what does the ReGenX generator do? The ReGenX generator solution reverses generator armature reaction and produces a complementary electromagnetic torque. And it's referred to, when you see it in the electric vehicle, it's referred to, we call it, well, it's regenerative acceleration technology. So, in conventional generators, in EVs, regenerative braking; in ReGenX technology, in EVs, regenerative acceleration. Okay? So what we do is we reverse and eliminate generator armature reaction from the equation. So this number, these are the mechanical watts that are required, currently required the input mechanical watts in conventional generators to deliver this output. We, with our innovation, can deliver the same output with 0 mechanical watts in the drive shaft. And I'm going to show you that. We have 3 prototypes that show that, and this is what we're going to get into next. So basically the demonstration, the first thing that I'm going to do is introduce you to generator armature reaction, motor action in the generator, EV regenerative braking. They all mean the same thing, a counter electromagnetic torque that the generator produces that requires us to add mechanical power in the drive shaft when we generate electricity. We're going to introduce you to the ReGenX generator, the load current delay. This is the component of the innovation that allows us to get rid of this and produce EV regenerative acceleration. We're going to basically, then we're going to go down to the technology commercialization aspect. This is what's going to interest you primarily. Where is the innovation now, and what does it take to go into production? So I'm giving you a quick overview of the innovation, the scope. The scope is global. All of the generators that are currently in use today on planet Earth, they're obsolete now. So if you guys are going to start manufacturing generators, the generators that you're going to be manufacturing are going to be eventually replacing all the generators currently in use on the planet. Okay, that's about it. You're good?